For finding the multiplicative inverse of a matrix, first of all, certain concepts are required. Number one is determinant of a 2 by 2 matrix. Let A is equals to A, B, C, and D be a 2 by 2 square matrix. The determinant of A denoted by DET, A or A determinant is defined as. Okay, so for writing the determinant, you will write the abbreviation of determinant, that is DET, and the name of the matrix, whatever the name is given. Like here in this case, matrix A is given, so you will write DETA. Or you can also write the name of the matrix with the two lines together, like one line on the left side and one line on the right side, like this. A. Whatever the name of the matrix, you just have to write the name of the matrix in two lines, one on the left side and one on the right side. So A is a matrix which is having the order 2 by 2, and it is a square matrix. We have to find the determinant of matrix A. How do we find the determinant? A determinant is equals to DET or det. If A is equals to determinant, we'll write the matrix A, B, C, and D. So determinant A is determinant matrix A, B, C, and D. Okay, now when we are taking the determinant, we will also write down the matrix within two lines. We will remove this square bracket. Both of the square matrix, both of the square brackets are removed, and you will use two lines for the determinant, like this. Now for the determinant, you have to multiply the diagonal entries. Multiply the diagonal entries in between, having the negative sign in between them. So A will be multiplied with B and B will be multiplied with C, having the negative sign in between them, right? So A will be multiplied with D minus B times C is equals to lambda. Okay, like they have just given a general term, that is lambda, and lambda belongs to rational numbers or real numbers. So here the numerical values are not given. We don't know the numerical values of A, B, C, and D. So they have just written that the values of A, B, C, D lies within the real numbers. They can be any values, either 1, 2, 3, 4, 5, or whatever. Any number can be assigned to the values of A, B, C, and D. Right?
Yes.
Have you understood?
Yes.
So the answer of their products and subtractions will give you any real number. Second case, let B is equal to 1, 1, minus 2, and 3. Then determinant of B, place the sign of determinant with B is equal to determinant of B is equals to, change the sign of the square brackets into the determinant sign, 1, 1, minus 2, and 3. It gives you just have to multiply the diagonal entries and subtract them. 1 multiplied by 3 minus 2 multiplied by 1. So 1 multiplied by 3 is 3 minus, okay, now here minus times minus is plus, Minus multiplied by minus gives you plus. So the sign will be plus. Okay, 2 multiplied by 1 is 2. So 3 plus 2 is 5. The answer is 5. Determinant of V is 5. This is the process for calculating the determinant of any matrix. Third example, if M is equals to 2, 6, 1 and 3, then determinant M is equals to, first of all, change the square brackets into the determinant sign. 2, 6, 1 and 3. It gives you multiply the diagonal entries. 2 multiplied by 3 minus 1 multiplied by 6. 2 multiplied by 3 is 6 minus 1 times 6 is 6. So 6 minus 6 gives you 0. So here the determinant is 0. The answer is 0. There will be a case in the further topics that what will we do if the determinant is 0, and what happens if the determinant is not 0. In one of the example, the determinant was not 0, and in the second example, the determinant is 0. M is 0. Okay. Then we have singular and non-singular matrix. Singular matrix. Singular matrix is a matrix. It is a square matrix if the determinant of that matrix is equal to 0. If the answer of the determinant of any matrix is equal to 0, then this is a singular matrix. Now we are applying the concept of the determinant, that if the determinant is 0, like we did in this example, determinant M, the answer is 0. So that kind of matrix is known as singular matrix. A square matrix A is called singular if the determinant of A is equal to 0. That is, A determinant is equals to 0. Now let's look at the example. For example, A is equals to 1, 2, 0, 0 is a singular matrix. How it is a singular matrix, we have to show it. Taking the determinant, when we take the determinant, we will multiply the diagonals, cross multiply the diagonals. 1 times 0 is 0, and 0 times 2 is 0. So 0 minus 0 gives you 0. That is a singular matrix because its determinant is equal to 0. Second concept is about the non-singular matrix. A square matrix A is called non-singular if the determinant of A is not equal to 0. So for the non-singular matrix, if the determinant of any matrix is not equal to 0, if it is any other number other than 0, like 1, 2, 3, 4, or 5, 6, etc., then it would be a non-singular matrix. A determinant is not equal to 0. For example, A is equals to 1, 1, 0, and 2. We'll find the determinant of matrix A. The answer is 1 times 2 minus 0 times 1. Cross multiply the diagonals and then subtract them. So 1 times 2 is 2 minus 0 times 1 is 0. 1 times 2 is 2 minus 0. 2 minus 0 is 2. And 2 is not equal to 0. So it means here the determinant of matrix A is not equal to 0. It is 2 other than 0. So it is a non-singular matrix.